Hey guys, coming at you with another wild video about math. This time we're talking about the triangle proportionality theorem. First we're going to talk about the triangle proportionality theorem is, then we're going to do a couple of examples, and this time a word problem's included. Word problems. But we're going to show you how to do this, and hopefully it will enlighten some of you. So let's take a look. So let's talk about what a theorem is. A theorem is a statement that's been proven true. Better yet, a theorem is a theory that's been proven true. So when we're saying theorem, we're saying the triangle proportionality was once a theory, and then it's been tested over and over and over again, consistently correct, so we then label it a theorem because it's true. There's no questioning it at this point. And the triangle proportionality theorem is if a line parallel to one side of a triangle intersects the other two sides, then it divides those two sides proportionally. So let's take a look at what that means. Okay. So I have these two problems here and they want me to solve it for x. Well, the first thing I notice is that I got these red arrows here. And those arrows are telling me that these lines are parallel. So this means parallel lines. That being the case, I know I could apply the triangle proportionality theorem, which means that these pieces here are divided by these lines, or these sides here are divided by these lines proportionally. So as a result of that, I can set up a proportion in order to solve it, and that's what I'm going to do. The way we do this, when we set up a proportion is two fractions equal to each other, is we follow a pattern. You could either go from this small piece to that large piece and then this piece to that piece, or you can go across. Either way will work, but you have to stay consistent. Now, I noticed that 10 and 15 are large numbers, so I'm going to go across. So I'm going to say 10 to 15, so 10 to 15, then 4 to that. Now, the reason why I did that is I looked ahead and I noticed that I can reduce this. And to be honest, I don't want to use my calculator. So I'm going to reduce that. So now I'm going to reduce that to, let's see, 2 over 3 equals 4, negative 2 plus 2x. Now, I don't want to get too fancy, but I could have reduced this a little bit too. All right, now I'm going to cross multiply. So cross multiplying requires me to take that 3 and multiply that 4, so that's 12. And then this statement here, or negative 2 plus 2x, and multiply that 2. So I'm going to do that. Okay, then I'm going to distribute. So the 2 is going to distribute to both of those. I do have another video that you could look for that's just solving proportions. Now I'm going to add 4 to undo that subtraction. And that's going to give me 16 equals 4x. Then I'm going to divide by 4 to undo that multiplication. And x is going to equal 4. That's how we do that. Okay? Alright, now, let me check out this one. This one's a little bit more difficult, in that I have the parallel lines again, but I'm in a situation where I'm missing this piece here. So I have a choice. I could either add these two together, so then this and this will correspond, or I could subtract this from there to get that piece. I'm going to subtract because I think that's the easier way to go about it. We got to learn that when we do these problems, that it takes some prior thought. we don't want to just grab our pen and just start scribbling out proportions. We want to think the problem through first. And like I said, I find it easier this time to subtract these pieces. So I'm going to do 28 minus 12, which is going to give me 16. I'm going to double check that. 16. That's where the calculator comes in handy. Okay. Now, I'm looking at my pattern here, and I have a bunch of big numbers. I don't like big numbers. They worry me. What I think I'm going to try to do is I'm going to pair these two up and those two up because I know I could reduce 12 over 16 by 4. So 12 and 16. So 12 to 16 then equals 15 to x plus 3. So 12 to 16, 15 to x plus 3. Now I'm going to reduce those. I can reduce those by 4. So I'm going to get 3 over 4 equals 15 x plus 3. Now I'm going to cross multiply. So that expression or statement is going to go to the 3. And then that 4 is going to go to the 15. So I'm going to get 60 equals 3 x plus 3. So now I have 60 equals 3x plus 9. Okay, I'm going to subtract 9. I'm going to get 51 equals 3x. Then I'm going to divide by 3. And let's see what I get. So 51 divided by 3 is 17. So x equals 17. And that's those two problems. Next, let's take a look at a word problem. Alright, here's your typical word problem. This is actually, I think, a standardized test question that was released. So let's see what we get. To measure the distance EF across the lake, a surveyor at S locates points E, F, G, and H as shown. What is EF? Alright, so in case you're wondering, this galacticus looking thing here is water. And is one of our triangle friends doing his surveying. Now, the best way for me to do this is to separate these two triangles. I know that this stuff is proportional, but the problem here is I need x. Though they didn't make it totally clear, these lines are parallel, so that makes everything similar. It actually makes it similar through angle, that postulate, in case you were wondering. So I'm going to separate my two triangles. Let's make that a little bit bigger. So this is the little one, and here's the big one. Okay. The little one, I have 24, 20, and 26. Now I gotta figure out the big one. Well, I have to add these sides together. So this is 54. Then that's x. And then this is, let's see, 26. 26 plus 31.5 is 57.5. Okay. So now I have those distances figured out. What I have to do from there is I have to set up a proportion. Now, a proportion only requires two of those sides. So I've immediately decided I'm not using that fraction. Or that decimal. I'm not going to make my life harder than it needs to be. So I'm going to go from 24 to 20. And so that's 24 to 20, 54 to x. And that's how I'm setting up my proportional. my proportion. 24 to 20 is very reducible, I think. So let's see what I can reduce it by. It's at least reducible by 2. So 24 over 20, and that's 6 over 5. Some of you may be wondering, wait a minute, why'd you do that extra step on the calculator if you couldn't just do it in your head? 54 is already a large number. 20 times 54 is going to be even larger. I don't want to typo this or make a mistake. And small numbers make that less likely. So I'm going to multiply the 5 times 54. And that gives me 270. And that gives me 6x. So now I'm going to reduce by 6, divide by 6 to undo that multiplication. And I divide, and that gives me 45 meters. And that's how we do that. Some of you, if you watched the video or know how to do it for side-side-side similarity, that's exactly the same process here. The only difference is this time we're solving for x. I shouldn't say exactly the same process. Very similar process. Okay? All right, guys. I hope you found this video on triangle proportionality theorem helpful.